Here's another example of one that's got some tricky things you need to do. So here I've got BC congruent to CD, and I have AB congruent to DE. And I want to prove that these two segments going across the middle here are congruent, BE and AD. Now, there's three pairs of triangles that might be congruent in this picture, and you have to pick out the correct pair to prove. And there's more than one way to do this problem, so I'm going to show you one way. One pair is these triangles that overlap down here at the bottom, and they share this side AE, BAE and DEA. A second pair is this butterfly triangle that I like to call butterfly triangle here in the middle. And the third is the pair that overlap and come up to the top at C. So I have ADC and I have ECD. I'm going to use that top pair. So let me get out my colored pencils. I'm going to show that this triangle here is congruent to this triangle here. So when I start to color my tick marks, this tick mark here, C to D, is pink. That goes from C to D. That's the side of the pink triangle. And its partner over here is green. Goes B to C. This down here is too short. This is not a full side of the green triangle. It only goes from here to here. But I can add to it CD. And on the other side, I could take this and add this. And I'll get this long green segment going from C to E, which I'll triple tick mark. So I have C to E, which I'll get by adding these two segments. And on the other side, I'll have C to A, which I'll get by adding these two segments. So this is, if I look at what I have tick marked now, in the green I have side, side. And in the pink I have side, side. So the way I'm going to finish this is I'm going to go SAS. I'm going to go side, angle, side. And this is the first time we've seen what I call a shared angle. If I look at this angle here at the top, up at C, it's an angle of the pink triangle because it goes from pink to pink, but it's at the same time an angle of the green triangle because it goes green to green. So this angle at C is what's called a shared angle. It's an angle of both triangles. It's not enough to have the same vertex. We've seen a lot of triangles that have the same vertices. To be the same angle, it actually has to be the same exact arc that goes from between two sides of the one triangle, in this case the pink triangle, and between two sides of the other triangle, the green triangle. And this forms my side angle side pattern. So here's how this would write up would look when I wrote it up. First of all, I have these two short sides, BC and CD, are congruent. That's a given. Then I have my angle at the top, which I can simply call angle C. It's the only angle with vertex C in this problem. That's the shared angle. It's an angle of the pink triangle, and also the same angle is the angle of the green triangle. So this is the same angle. And then we have this long third side of each of the two triangles. Look at this. For the green, I have side, angle, side down to here. There's the green triangle. And then in the pink one, I have side, angle, side. So to show that C to E is congruent to C to A, that's the third pair of sides, I have to do an addition argument. So I'm going to take BC and add AB. When I add those together, when I join those segments together, I get a segment that goes from A to C. And on the other side, I have CD to DE. And that gives me C to E. Again, this addition argument is only valid if I know both of these are true, if I have reasons, but these again are both given. That's a given, that's a given, so this is a legitimate argument. It's a valid argument. So by combining these three things together, I get triangle DCA, that's the pink one, is congruent to triangle BCE. That's the green one. And that's a side angle side argument. And then I'm trying to show that BE and AD are the same, and those are indeed, each of those are a side of these two triangles. So I'll have BE congruent to AD because they are corresponding sides.